I'm Anil Kumar. Let me thank all the viewers and subscribers to watch my videos and post excellent questions. Here is a request from one of our subscribers. The question is based on derivatives optimization. I hope its solution will help many others. The question here is, a cylinder of height y is inscribed in a right circular cone with height and base of h. The base of the cylinder lies on the base of the cone and top part of the cylinder touches the curved surface of the cone. If the base radius of the cylinder is x and the height of the cylinder is y, then show that y is equals to h minus 2x. So that's the first part, right? The second part is to express volume of cylinder in terms of x, and the third part is to show that the volume of the cylinder is a maximum with value of x equals to h by 3. So we are given a diagram here. The triangle indicates a cross section of this cone, and this rectangle is the cross section of the cylinder. So the top of the cylinder is touching the circumference of the cone, right? And the base is aligned and it is inscribed completely in the cone. Now we are given some dimensions here. So let me place those values. So we are given that the height of the cone is h, and let me draw a line in between. We are given the base is also h, right? So this base is also h. So half of this will be h by 2. Clear. So those are the dimensions of the cone. And now let me write down the dimensions of the cylinder, which are given to us as the base radius of the cylinder is x, so this is the radius, so this is x. And the height of the cylinder is y, so this height is y for us. Correct? So this is x and that is y. Now to get the relation between y, height and x, what we should do is we should consider the similar triangles, right? So let me label the triangles which we are interested in. Let's say this is A, B, and C. Let this point be D, and here we'll have E and F. And let's say this point is, let's say P. Okay. So in that case, we see that the triangle ADC, the big triangle, is similar to the smaller triangle. Let's take this point as Q, FQC. Right? So the big triangle is similar to FQC since they have a common angle, right? These sides are parallel, that is 90 degrees. So from the property of A. Now if you have similar triangles, in that case the ratio of the sides will match. So we have AD over DC should be equal to FQ over QC, right? Now AD is given to us as height of the cone. D to C is half the height of the cone, h by 2, right? F to Q is given to us as y, and Q to, I should have written C, sorry. Q to C is what? Q to C is h by 2 minus x. Correct? So QC is this dimension, which is h by 2 minus x, right? Now, here h and h cancel. We get 2 on the numerator. We have y. We can take 2 common factor here. common denominator with h minus 2x, right? And this 2 goes there. So we get 2y. Now we can cross multiply and cancel this 2. So we have 2 times h minus 2x equals to 2y. So we have our relation that h minus 2x is equal to y, correct? So first part we could do with similar triangles. Is that clear? Now, express the volume of the cylinder in terms of x. Now, volume of a cylinder is pi r square h. So radius is x for you and height is y. So we know radius is x and height is equals to y. Substituting, we get this volume as pi x square a y. Now we know y is h minus 2x, so we could write this as pi x square h minus 2x, as we just derived in equation 1, right? So we sub 1. Now what you notice here is all the terms are in terms of x. H is a constant, right? So we get volume in terms of x. So that becomes our function in terms of x, right? So that helps us to find the solution of the second one, correct? Now part 3 is we need to show that the volume of the cylinder is a maximum. The value of x is h over 3. Now, to show the maximum, there are a couple of ways to do it. If we use calculus, we can find the derivative, right? So let's find the derivative of this function. So the derivative, we know h is a constant. So before we find derivative, let me rewrite this by opening the brackets and it will be simpler. Pi, h is a constant, x square minus, open the bracket that is, 2 times pi x cube, right? Now let's find the derivative. So it will be simpler. We just use the product rule. So derivative of this will be 2 pi hx minus 3 times 2 is 6 pi x square. And you can factor 2 pi here. So when you factor 2 pi, you can factor x also. You get h minus 3x. So that becomes the derivative. Now from this derivative, we can find the critical numbers, right? So we just proved here that y is equals to h minus 2x. Now here we will find the critical numbers. Critical numbers is when this volume is equal to 0, right? Or undefined. In this case, it could be only 0. So we'll consider those. So we get the critical number since the derivative is equals to 2 pi x times h minus 3x. We have two critical numbers, which is x equals to 0 or x equals to h by 3, right? Only then it can be 0. So we got critical numbers 0 and h by 3. We have to show that the maximum occurs when x is equals to h by 3. Now remember that this x has a defined boundary condition. So we can write that this x value is actually only between 0 and h by 2. Now since we have a boundary condition, we can find the volume at all the 3 points, the boundary and the critical number. So the volume at x equals to 0, if I substitute, volume formula we already have here, which is this formula, right? So if I substitute 0, I get this as 0, right? The other boundary condition is h by 2. That also gives us 0, since the other factor will be 0. So you're trying to link these two. Correct? So definitely, the value h by 3 will give you the maximum, right? So let's substitute the value h by 3 now. So if you substitute the value of h by 3, you get the volume, which is the maximum volume, right? So this will be positive and therefore maximum. Is that clear? In this question, we are not really asking for what is the maximum volume, right? So, which you could find. So if I substitute h by 3, we could actually substitute here and get the answer for x, because pi times h square, substituting h by 3 times h minus 2 h by 3, correct? So that gives you a value which is pi times h square times, this is 3h minus 2h, which is h over 3, correct? So sorry, h by 3 will mean this x value I omitted in this case here. It was pi x squared, so h by 9, right? So this was 9, sorry. If I substitute h by 3, so x value will be square of h and 3, right? So that gives you a value of pi h cube over 9 times 3, 27. So that is going to be your maximum value for the given condition, right? But anyway, we have shown that, so it has maximum at x equals to h by 3. So we have shown the last part also. So I hope these steps are absolutely clear. You understand how we got about it. Well, if you're not done calculus, at this stage, you could do completing the squares and find that the vertex is at h by 3, right? You could do that. So I hope it makes sense. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.